I can start, I can send it to you. How's that sound?
That's good.
Okay, because there's about, looks like there's about 9 problems. So hopefully if we go over them, you'll feel a little bit better about it.
Yeah.
Okay? All right, so what I'm going to do is I'm going to share my lap, my desktop with you. It'll probably take a second to kick in, so just let me know when you can see it.
I can see it.
Okay. And so let's just kind of go through frame by frame. So this is the assignment you're referring to, correct?
Yes.
Okay. So let me go ahead and grab this because I can write on this. I can't write on the screen. Okay, so this says to determine the total number of roots. Now, the key here is number one, just understanding what it is that they mean by the word roots. The roots are sometimes referred to as the zeros of the function.
Oh, okay.
Okay, so you determine the number of roots by taking the degree. So you want to know what the degree is. And the degree is always the largest coefficient. So in this particular example, 6 are the number of roots that it has because 6 is the largest
Yeah.
value. Now, in the next question here, when you square this, you're going to end up with 9x to the 8th,
Um,
etc. Because if you took 3x to the 4th plus 1 times 3x to the 4th plus 1, you'd FOIL that out, and that's where you'd get that largest exponent of 8.
mhm.
Does that make sense?
Yeah, like I got this part, but like it started getting harder.
Okay, and so then this is 2, and of course this one, when you multiply this one out, you just get an x squared, but we have a cubed here, that's why that's 3. So no question in identifying how many roots there should be. Is that correct?
Yeah, I'm fine with this part.
Okay, so let's look at the next question. It looks like this question is the same. So are you saying you're comfortable with this as well?
Yeah.
Okay. Okay, all right. So let's talk about what's happening here. It looks like maybe you have some questions about this. Is that right?
Yeah.
Okay. All right. So a root, as I explained before, is actually a zero of the function. So in this first example here where it says x minus 6 squared and then x plus 2 squared, that means that that's x minus 6 times x minus 6 times x plus 2 times x plus 2.
Mhm.
Does that make sense?
Yes.
So to find the roots, I would take each one of these and set them to equal to 0. Well, of course, x minus 6 and x minus 6 are going to give us the same 0 of the function, which is 6,
Yeah.
right?
Mhm.
And x plus 2 and x plus 2, that's going to give us the same one, which is x to the negative 2, correct?
Yes.
All right, so the first choice and the second choice don't make any sense. So we're going to cross them out because they say negative 6. The same thing with the last two choices. Those don't make any sense either because they say positive 2, and we know that our 0 is a negative 2. Does that make sense?
Yes.
Okay, so these are my only options. So for the 6, it appears twice, once and then again. So the answer is 6 with a multiplicity of 2.
Okay.
And the negative 2 also is twice, so that's negative 2 with a multiplicity of 2 because it appears twice.
That makes more sense because like on the video, it seemed kind of confusing on like this like the guy was like dropping down a bunch of numbers and it was kind of confusing with the word multiplicity.
Okay, so let's look at the next example. I'll let you do it. So I've got three different factors here, right?
Yes.
When I said each one of them equal to 0, so when I said the first one equal to 0, what am I going to get? X equals
-5.
-5. It's raised to the third power, so that means it's a
It's a
multiplicity.
multiplicity of 3.
Right, so that's your choice number 1. Does that make sense?
Yeah.
So what will your next one be? That'll be x equals,
It'd be x equals 9 to a multiplicity of 2.
and so that is right down here.
Oh, this is much more easier now.
Okay. And what about the last one?
The last one is x equals 1 with a multiplicity, or -1
Negative
with a
1,
multiplicity of 1.
1, because it only appears one time. Good?
Yes.
All right, good. Let's look at this next one. Okay. So, x-intercepts is another way of saying roots. Okay? So remember I said you can use the word roots and it can mean zeros, but it also means x-intercepts. So that's where it crosses the x-axis. Okay? But it only crosses the x-axis if it's a real number. So for example, in this first problem here, I get x equals -1, x equals 3, and x equals 4. So all three of these are real numbers, correct?
Yeah.
So that means that it has 3 x-intercepts. Now, over here, I get x equals -5, x equals 9, and x equals -1. Again, these are all real numbers, correct?
Yeah.
So the -5 does have a multiplicity of 3, but we'll talk later about what that means as far as what the graph looks like. But it still is just 3 x-intercepts, so it's only going to cross the x-axis or touch the x-axis 3 times. Good?
Yes.
Okay. So on this problem here, I get x equals 6 and x equals -2. Now, even though each of them have a multiplicity of 2, all the multiplicity of 2 means is that at -2, the graph kisses the axis. It makes it look like a parabola there. And then
Okay.
over at 6, it kisses the axis again. So this graph would look something like this if you were to sketch it. But there are only 2 x-intercepts.
Oh, okay.
So it only touched the axis twice. Now in the last problem here, we have x equals -2, x equals +1, but over here we end up with, we have this imaginary numbers. Do you see that?
Yeah.
And you never have one imaginary number. If you're going to have one, you have to have the other one. They're conjugates of each other. Notice that this is 4 plus 3i and this is 4 minus 3i. So when you always will have the imaginary numbers come in pairs.
Oh.
But imaginary numbers don't touch the x-axis. So what this looks like here is you have your graph is going straight through at -2, and then it's going straight through at +1, and then it probably turns something like that. And over here are the imaginary numbers where it doesn't cross the x-axis. So since it only has 2 real zeros, then it only has 2 x-intercepts.
Yes.
Now, the imaginary numbers are roots. They're just not x-intercepts. That's the difference.
Oh, okay.
Does that make sense?
Mhm.
Okay. Let's look at the next one. I don't know which one that was. I feel like it was 4 or 5.
Is 5.
Okay, let's go to 6. All right, so here they're saying choose the answer that best completes the following sentence. And remember, this all goes back to that whole idea of understanding the difference between a root or an intercept. But it says, if you know that you have a root, that is -2 plus square root of 3i. So see, this is one of those imaginary numbers, right?
Mhm.
So that tells us that we have to have another root, which is its conjugate, because the imaginary numbers come in pairs. So you have to have another root that's -2 minus square root of 3i.
Oh, okay.
So it says 2 plus, oh, I'll have to put in this is wrong. It would be -2 minus 3i is the other root.
Oh, okay.
So this one should have a minus here. I'll let Ingenuity know that. But it always has the conjugate as well as a root. All right, so let's take a look at this one. Okay. So this one here is telling you that here is your equation. Now, how many roots does this whole equation have?
3 or no. 5.
5 roots. Now, it's telling you that 3 roots of this are -1, 1, and then you have 3 plus I. Well, you know if you have 3 plus I that you also have 3 minus I, correct?
Yeah.
Because these imaginary numbers have to come in pairs.
Mhm.
So you know you're going to have at least 2 imaginary numbers. And then what's that 5th root going to look like? Real or imaginary? Because I need a total of 5. So I know 2 are real and 2 are imaginary so far. So what's the 5th one going to be?
Real.
Real. We don't know what it is, and they're not asking us to find it right now. We just know that we also have another real root.
Okay.
And so the answer is that it has 3 real roots and 2 imaginary. Now, let's go through these choices just really quick here. It has 2 real roots and 1 imaginary. Well, it can't have just 1 imaginary, so then we know that that's not an option. Next, it says it has 3 real roots. Well, it does have 3 real roots, but it also has 2 imaginary. So you want to be careful which answer you choose.
Yeah.
Okay? All right, so on the next one here, it's saying to identify all the roots of this equation, okay? So what it means to identify all the roots is that you need to go ahead and factor each one of these, and set each factor equal to 0. So what does x squared plus 3x minus 4, what does that factor to?
X. Wait, I had it somewhere.
That's okay, take a minute.
X plus 4 and x minus 1?
X plus 4, x minus 1. That's correct. And what about this second one? Does this factor?
I don't think so because
It doesn't. So what we can do, first of all, we can solve here. We know this is x equals -4 and x equals 1, correct?
yeah.
So we know that these two are choices, okay? Which means these two are not choices.
Yeah.
Because the other one doesn't factor. So now what we can do is we can solve for x here by completing the square. Do you remember how to do that?
I kind of forgot a little bit.
All right, we want to move the 29 to the other side. And that gives us -29. Correct?
Yes.
Then we're going to make this a perfect square. So we're going to do x minus 2 because 2 is half of 4. And then we're going to add 4 to both sides. And this is going to give me -25 on this side.
Okay.
You still with me?
Yeah.
Is it coming back? Take the square root of both sides and I get x minus 2 equals plus or minus the square root of -25. Well, that's one of those complex numbers. So what is the square root of -25?
It's an imaginary number.
It is. So it's plus or minus 5i. Correct?
Yeah.
And then we're going to move the 2 over, and I get x equals 2 plus 5i and 2 minus 5i. And remember, that's partly because our imaginary numbers come in pairs. I know I repeat myself a lot, but questions?
No.
Okay, let's go ahead and look at this last question. Okay, so on this last question here, it's asking you to describe the roots, okay? Well, first here it says 2 roots of a polynomial function, x cubed minus 7x minus 6, are -2 and 3. It says using the fundamental theorem of algebra and the complex conjugate theorem, that's the one that says that you can't have one imaginary, there has to be 2. To determine the number and the nature of roots that remain. Explain your answer. Now you put the 2 roots of the quadratic are distinct and real. Once you solve the discriminant part of the equation, you will find that b is greater than 0, which means 2 roots are distinct. Now here you're not using the discriminant. The fundamental theorem of algebra tells me how many roots should I have in this function?
3.
I should have 3 roots because it's to the 3rd degree, correct?
Yes.
So that's what the fundamental theorem of algebra tells me.
Okay.
Okay. Now, the other one is the complex conjugate theorem. If I know that 2 of the 3 roots are real, what do I know about the 3rd root? The 3rd root, what?
It must be real.
Must be real. And that's because you cannot have one imaginary number. Does that make sense? Okay, so it says, did your answer include in the following? So you have to talk about the degree of the polynomial. That's why we say 3 roots, because it's to the 3rd degree. By the fundamental theorem of algebra, the function has 3 roots. That's what we said, 3 roots. 2 are given, so there must be 1 remaining. That's true. We talked about that. And so it says by the complex conjugate theorem, since they have to come in pairs, the final root is real.
Okay.
Does it make sense, honey?
Yeah, it does.
Okay. So that's the assignment. I can reset the assignment since you just made a 73 on it if you want to try that assignment again.
Can I try it again?
Yeah, you just actually made a 70 on it. So you can try it again prior to taking that quiz.
Okay, and then I'll take the quiz.
Okay, let's just take a quick look here. You are at your progress report as long as I've got you on the phone. So looks like you're doing really well. So you should be at 76%. You're only 1% behind, and I'm sure that's because you were waiting to take your quiz today. The good news is that you still have that 83 in the class. Okay.
Mm-hmm.
If you get ahead over the weekend, or not over the weekend, I'm sorry, over the Thanksgiving break next week, if you want to redo any of these assignments like you did the last time, you can redo them.
Okay.
Okay? Now, the final exam is going to be the EOC. That's what we're going to talk about. Are you and your mom going to join us for that Skype meeting this afternoon?
Oh.
Or this evening, I should say. It's at 7 o'clock.
Oh.
6 or 7. I sent out an email about that. Let me check, see what the exact time is. It is accelerated parents. It is at 7 o'clock.
Okay.
Did you get that email?
I probably did. Let me check.
I sent it out, I don't know, a couple days ago.
I don't think I have it.
Okay, so I'm going to resend it actually to all the parents at 5 o'clock. So look for it. It's just another link like this one into the Skype meeting, except a lot of people are going to be joining the meeting. And we're just going to go over the basics of what the EOCT is about and the practice that's available.
When is it, the EOCT?
The EOC is in December.
Oh, okay.
Okay?
Yeah.
All right. And do you have any other questions for me?
No, not really.
Okay. All right. Sounds good. Then I'm going to go ahead and stop the recording. It usually takes